In meteorology, a cloud is an aerosol comprising a visible mass of liquid droplets or frozen crystals made of water or various chemicals. The droplets or particles are suspended in the atmosphere above the surface of a planetary body. Terrestrial cloud formation is the result of air in any of the lower three principal layers of Earth's atmosphere becoming saturated due to either, or both of two processes: cooling of the air and adding water vapor. Cloud types in the troposphere, the atmospheric layer closest to Earth's surface, have Latin names due to the universal adaptation of Luke Howard's nomenclature. It was formally proposed in December 1802 and published for the first time the following year. It became the basis of a modern international system that classifies these tropospheric aerosols into several physical forms which can be found at various altitudes, levels or etages. One physical form appears as non-convective stratiform sheets in stable air. If the air mass is slightly or partly unstable, limited convective stratocumular rolls or ripples may appear. Both these layered forms have low, middle, and high etage variants. Cloud types in the two upper etages are identified respectively by the prefixes alto and cirro. Thin or occasionally dense cirriform filaments are found only at high altitudes of the troposphere and may form in stable or partly unstable air. More generally, unstable air tends to favor the formation of free convective low or multi-level cumuliform heaps. Strong air mass instability or cyclonic lift can produce storm clouds with significant vertical extent through more than one etage. Prefixes are then used whenever necessary to express variations or complexities in their physical structures. These include cumulo for complex, highly unstable cumulonimbus-form thunderclouds, and nimbo for stable multi-etage stratiform layers with sufficient vertical depth to produce moderate to heavy precipitation. This cross-classification of forms and etages produces 10 basic genus types or genera, most of which can be divided into subtypes consisting of species that are often subdivided into varieties where applicable. Clouds that form above the troposphere have common names for their main types, but are subclassified alphanumerically rather than with the elaborate system of Latin names given to cloud types in the troposphere. Clouds have been observed on other planets and moons within the solar system, but, due to their different temperature characteristics, they are often composed of other substances such as methane, ammonia, and sulfuric acid as well as water. Etymology. The origin of the term cloud can be found in the Old English clud or clot, meaning a hill or a massive rock. Around the beginning of the 13th century, it was extended as a metaphor to include rain clouds as masses of evaporated water in the sky because of the similarity in appearance between a mass of rock and a cumulus heap cloud. Over time, the metaphoric term replaced the original Old English wheel can to refer to clouds in general. The science of clouds is nephology, which is undertaken in the cloud physics branch of meteorology. History of cloud science and nomenclature. Aristotle and Theophrastus' ancient cloud studies were not made in isolation, but were observed in combination with other weather elements and even other natural sciences. In about 340 BC, the Greek philosopher Aristotle wrote Meteorologica, a work which represented the sum of knowledge of the time about natural science, including weather and climate. For the first time, precipitation and the clouds from which precipitation fell were called meteors, which originate from the Greek word meteoros, meaning high in the sky. From that word came the modern term meteorology, the study of clouds and weather. Meteorologica was a work of intuitive rather than scientific study. Nevertheless, it was the first known work that attempted to treat a broad range of meteorological topics. The book De Mundo noted, "Cloud is a vaporous mass, concentrated and producing water. Rain is produced from the compression of a closely condensed cloud. varying according to the pressure exerted on the cloud. When the pressure is slight, it scatters gentle drops. When it is great, it produces a more violent fall, and we call this a shower, being heavier than ordinary rain, and forming continuous masses of water falling over Earth. Snow is produced by the breaking up of condensed clouds, the cleavage taking place before the change into water. It is the process of cleavage which causes its resemblance to foam and its intense whiteness, while the cause of its coldness is the congelation of the moisture in it before it is dispersed or rarefied. When snow is violent and falls heavily, we call it a blizzard. Hail is produced when snow becomes densified and acquires impetus for a swifter fall from its close mass. The weight becomes greater and the fall more violent in proportion to the size of the broken fragments of cloud. Such then are the phenomena which occur as the result of moist exhalation. Several years after Aristotle's book, his pupil Theophrastus put together a book on weather forecasting called the Book of Signs. Various indicators such as solar and lunar halos formed by high clouds were presented as ways to forecast the weather. The combined works of Aristotle and Theophrastus had such authority they became the main influence in the study of clouds, weather and weather forecasting for nearly 2,000 years. Luke Howard and Jean-Baptiste Lamarck, after centuries of speculative theories about the formation and behavior of clouds, the first truly scientific studies were undertaken by Luke Howard in England and Jean-Baptiste Lamarck in France. Howard was a methodical observer with a strong grounding in the Latin language and used his background to classify the various tropospheric cloud types during 1802. He believed that the changing cloud forms in the sky could unlock the key to weather forecasting. Lamarck had worked independently on cloud classification the same year and had come up with a different naming scheme that failed to make an impression even in his home country of France because it used unusual French names for cloud types. His system of nomenclature included 12 categories of clouds, with such names as hazy clouds, dappled clouds and broom-like clouds. By contrast, Howard used universally accepted Latin, which caught on quickly after it was published in 1803. As a sign of the popularity of the naming scheme, the German dramatist and poet Johann Wolfgang von Goethe composed 4 poems about clouds, dedicating them to Howard. An elaboration of Howard's system was eventually formally adopted by the International Meteorological Conference in 1891. First comprehensive classification. Howard's original system established 3 general cloud forms based on physical appearance and processive formation: cirriform, cumuliform or convective, and non-convective stratiform. These were cross-classified into lower and upper etages. Cumuliform clouds forming in the lower level were given the genus name cumulus from the Latin word for heap, and low stratiform clouds the genus name stratus from the Latin word for sheet or layer. Physically similar clouds forming in the upper etage were given the genus names cirrocumulus and cirrostratus, respectively. Cirriform clouds were identified as always upper level and given the genus name cirrus from the Latin for fiber or hair. In addition to these individual cloud types, Howard added 2 names to designate cloud systems consisting of more than one form joined together or located in very close proximity. Cumulostratus described large cumulus clouds blended with stratiform layers in the lower or upper levels. The term nimbus was given to complex systems of cirriform, cumuliform, and stratiform clouds with sufficient vertical development to produce significant precipitation, and it came to be identified as a distinct nimbiform physical category. Howard's successes in 1840. German meteorologist Ludwig Ketz added stratocumulus to Howard's canon as a mostly detached low-etage genus of limited convection. It was defined as having cumuliform and stratiform characteristics integrated into a single layer. This led to the recognition of a stratocumuliform category that included rolled and rippled clouds classified separately from the more freely convective heaped cumuliform clouds. During the mid-1850s, Emmeline Renoux, director of the Parc Saint-Maur and Montsourish observatories, began work on an elaboration of Howard's classifications that would lead to the introduction during the 1870s of altocumulus and altostratus. These were respectively stratocumuliform and stratiform cloud genera of a newly defined middle étage above stratocumulus and stratus but below cirrocumulus and cirrostratus. In 1880, Philip Weilbach, secretary and librarian at the Art Academy in Copenhagen, unlike Luke Howard, an amateur meteorologist, unsuccessfully proposed an alternative to Howard's classification. However, he also proposed and had accepted by the Permanent Committee of the International Meteorological Organization, a forerunner of the present-day World Meteorological Organization, the designation of a new free convective vertical or multi-étage genus type, cumulonimbus, which would be distinct from cumulus and nimbus and identifiable by its often very complex structure, and its ability to produce thunder. With this addition, a canon of 10 tropospheric cloud genera was established that came to be officially and universally accepted. Howard's cumulostratus was not included as a distinct type, having effectively been reclassified into its component cumuliform and stratiform genus types already included in the new canon. In 1890, Otto Jessie revealed the discovery and identification of the first clouds known to form above the troposphere. He proposed the name noctilucent, which is Latin for night shining, because of the extremely high altitudes of these clouds in what is now known to be the mesosphere. They could become illuminated by the sun's rays when the sky was nearly dark after sunset and before sunrise. 3 years later, Henrik Mon revealed a similar discovery of nacreous clouds in what is now considered the stratosphere. In 1896, the first cloud atlas sanctioned by the IMO was produced by Teicherance de Water based on collaborations with Hugo H. Hildebrandsson. The latter had become the first researcher to use photography for the study and classification of clouds in 1879. Alternatives to Howard's classification system were proposed throughout the 19th century. Heinrich Dove of Germany and Elias Loomis of the United States came up with other schemes in 1828 and 1841 respectively, but neither met with international success. Additional proposals were made by André Poey, Clement Ley, and H. Clayton, but their systems, like earlier alternative schemes, differed too much from Howard's to have any success beyond the adoption of some secondary cloud types. However, Clayton's idea to formalize the division of clouds by their physical structures into cirriform, stratiform, floccuform, and cumuliform eventually found favor as an aid in the analysis of satellite cloud images. 20th-century developments. A further modification of the genus classification system came when an IMC Commission for the Study of Clouds put forward a refined and more restricted definition of the genus Nimbus, which was effectively reclassified as a stratiform cloud type. It was then renamed Nimbostratus and published with the new name in the 1932 edition of the International Atlas of Clouds and of States of the Sky. This left cumulonimbus as the only nimbiform type as indicated by its root name. On April 1, 1960, the first successful weather satellite, TROS-I, was launched from Cape Canaveral, Florida by the National Aeronautics and Space Administration with the participation of the U.S. Army Signal Research and Development Lab, RCA, the U.S. Weather Bureau, and the U.S. Naval Photographic Center. During its 78-day mission, it relayed thousands of pictures showing the structure of large-scale cloud regimes, and proved that satellites could provide useful surveillance of global weather conditions from space. In 1976, the United Kingdom Department of Industry published a modification of the International Cloud Classification System, adapted for satellite cloud observations. It was co-sponsored by NASA and showed a change in name of the nimbiform type to cumulonimbiform. Although the earlier name and original meaning pertaining to all rain clouds can still be found in some classifications,